right, the next topic we're going to talk about are arguments. No, this is not a fight you get into with someone else, but a logical argument. So logical arguments have two parts. There's a set of premises, okay, so things that like would have to happen before you could ever say this other thing was going to happen. And then there's a conclusion that is based on those premises. The premises are the statements that offer supporting evidence for the conclusion. Okay, our only goal, is to decide if an argument is valid or invalid. An argument is considered to be valid if the conclusion follows from the premises. Okay, otherwise, the argument is invalid. Now remember, and we've been saying this the whole time, the definition of valid does not mean it's true, okay? It just means, can we conclude this based just on the premises, no matter how ridiculous they may seem, okay? The truth or falsehood of the statements themselves can be debated later, but that is not what logic is about, okay? Remember, logic takes out all of the emotion. So, here in this box, you kind of have the steps that we're going to follow. So first we're going to take our argument and we're going to write it in symbols, which means we have to, yes, identify the simple statements and write and give them variables. We will write the argument as a conditional statement. So like an if-then, and we use a conjunction, remember that's and, between all the premises and the implication symbol, which looks like an arrow with like a double thick line or whatever for the conclusion. That basically, it means the exact same thing as the if-then arrow. It just shows that this is particularly an argument. Then we make a truth table for premise, and premise implies conclusion. And then if the last column is a tautology, and that word just means all of the outcomes in that column are true, okay, then the argument is valid. Otherwise, it's invalid. So let's go to the next page here and walk our way through an argument, most of which I have written out for us. Okay, so let's decide if this argument is valid. If Mark is taking a composition course, then he won't take speech. Mark is taking a speech course. Therefore, Mark isn't taking a composition course, okay? So, just a couple of things here. So this one here, this first one is a premise, okay? This next one is also a premise. And then under the line, that's where the conclusion comes in, okay? And that's often how we write arguments. So first thing is identify the simple statements and assign variables. So I have done that, okay? P is defined as Mark is taking composition, and Q is Mark is taking speech. Now remember, we always write our statements in the affirmative, okay, not in the negative. So Mark is taking speech. So our first premise, so taking that first sentence up there, if Mark is taking composition, then he won't take speech, would be P, and then our if-then arrow. So if he's taking speech, then he's not Q, or sorry, if he's taking composition, sorry, then he's not Q taking a speech course. There's our premise, okay? The next premise is he's taking speech, so that would be Q. The conclusion as written is Mark isn't taking composition, so that would be not P, okay? And those three little dots, that just means therefore. You're really not going to have to focus on that too much at all. It's just one of those habits that that I've had for years, and it's not one that I'm going to break. Okay, so that just means therefore. And again, you can write the therefore dots, or you don't have to. All right, so that was step one. Step two, write the argument as a conditional statement using a conjunction between premises. Okay, so in other words, premise one. So we've got our if P, then not Q. And, okay, you'll always include that little and symbol. And then we've got our second premise, Q. And then our implications, this just means we're trying to make an argument here, okay? And does that give us not P? And this is what we're trying to figure out, okay? So from there, we go to a truth table. So we first have our P's and our Q's, and I've filled in a couple of spots for us. I've done the not Q column and the not P column, again, just to save a little bit of time, but there are some other things we need to look at. So if I did the not Q part, the next piece we would look at is the if P, then not Q. So remember looking at if P, then not Q, what would happen? Well, the only time, remember, that an if-then statement is false is if the first part, the if, is true and the then part is false. And we have that one time here in the first row. So that would be false. All of the rest would be true. Okay, now I'm going to delete the red parts here that I highlighted. All right, so the next part that we're going to go to is we would go ahead and look at then this entire statement here on the left-hand side. So that's the if P, then not Q, and Q. So again, looking at what's going on, we want this column, the one we just filled out. I'm not going to highlight the letters because I know what happens when I do. And our Q column. And in order for an and to be true, remember, both of those things have to be true. Well, looking, we only have one place that happens. Sorry, pen. One place that happens, right there. All the rest have a true and a false. And so all the rest of those statements must be false. Okay. Then again, I did the not P column for us already, okay? So then the last thing to do is to take the entire argument and see what happens. Now, I do have square brackets around the whole thing, just to show that it's the entire left side leading to the right side. If you want to use parentheses instead, you can. But again, just as we've talked about in other units, sometimes for me it's easier to see those when I make them different. Okay, so the rounded parentheses versus the square brackets. So the last thing that we need to do is then evaluate the whole statement, which is on the left. So that's this column right here. And our not P column right here. And this is, again, with an arrow, this is an if-then statement. So the only time the if-then is false is if we have a true implies false. Okay, well, I have false implies false. That's valid, or true. I have a false implies false, also true. A true implies true is true, and a false implies true is true. Okay, so what it boils down to is what we find right here in this last column. Okay, that is again what is called a tautology. You're not going to have to worry about that word a ton. Okay, but all of the truth values are T's. They're all trues. So the argument is valid. Otherwise, it would be invalid. So looking at that column, the argument is a tautology, and therefore the argument is a valid argument.